In this video, let's take a look at problems 413 and 414. Both of these consist of problems concerning constructing teams from a group of two different sets of people. Suppose that a group of 20 consists of 8 men and 12 women. How many four-person teams contain at least one man? Well, first let's figure out this question. How many four-person teams are there? And forget about the fact that it would contain a man or not. If we have a group of 20 and we construct a four-person team, then there's 20 choose 4 ways of doing that. Now, what's the opposite of at least one man? At least one man would be containing no men. So if there are no men, then that means the committee contains only the 12 women, or 4 of the 12 women. Now, how many ways are there of constructing a team of 4 from 12 women? Well, the answer would be, by the same logic, 12 choose 4. That's a combination of picking 4 people from a group of 12. So there are 20 choose 4 ways of picking 4 people from all 20. There's 12 choose 4 ways of picking 4 people from just the 12 women. So if I subtract, this would be the number of ways that I can construct a team that has at least one man. This is the total number of teams. This is the teams with 0 men. And so if I subtract, that would be the teams with at least one man. And so this works out to be 4,845 minus 495, which works out to be 4,350. So there's 4,350 different ways of constructing a 4-person team that has at least one man. All right. Problem 414. A class consists of 20 students with 12 men and 8 women. Of the 12 men, 3 are seniors. Of the 8 women, 2 are seniors. Number 1, find the number of ways to construct a 6-member committee consisting of 3 men and 3 women. Okay, so this way there's 12 men and we pick 3. So this would be 12 choose 3. And that's the number of ways of picking the men on the committee. There's 8 women, and we pick 3 of them, so there's 8 choose 3 ways of picking the women on the committee. So we need to pick the men on the committee, and we need to pick the women on the committee. Operative word here is and. I multiply these two by the product rule. Here are the number of ways of picking the men, here are the ways of picking the women, so I multiply to find the total number of ways of picking the members of the committee. So this would be 220 times 56, which works out to be 12,320. So that's the answer for number 1. Number 2 is more interesting. We again have a 6-member committee. Of the 6 members, 1 person is the chair, and we want 3 men and 3 women, but we also are going to require that the chair must be a senior. All right, now there's 2 possibilities. The chair could be a senior man, one of these 3, or the chair could be a senior woman. Okay, so let's do this. The ways of getting a senior man is going to be, there's 3 men that are seniors. So there's 3 men that are seniors. We pick one of them to be my committee chair. Clearly, 3 choose 1 is simply going to be equal to 3. Okay, then we've picked 1 person here. I need now to pick 2 other men to round out the committee. So there's 11 men that I have not chosen yet, and 2 of them I picked to be on the team. Now notice that I don't have 9 choose 2, 11 choose 2. There's nothing in the problem that says that the other people on the committee can't be seniors. So the first person's a senior, then of the 11 people that are left, we pick 2. Okay, then by this way, we pick the other members of the committee from the 8 women, 8 choose 3. And so that would be one way of doing things. And so this would be equal to 3 times 55 times 56. And do the arithmetic real quick. That is equal to 9,240. That's if the committee chair is a man. Now the other way that this can happen is if the committee chair is a woman. Now there's only 2 senior women that are available. Then, if we pick the 3 men out of the 12, and then we pick from the 7 remaining women, we pick 2 of them to round out the committee. So this would be equal to 2 times 12 choose 3, which is 220, times 7 choose 2, which is 21. So we get 2 times 220 times 21, which works out to be, coincidentally, 9,240. Now that is a complete luck of the draw accident by these problems. That doesn't necessarily happen all the time. So this just happened to happen that I got the same number twice. Okay, so the total number of ways would be 9,240 if we have a chair that's a man, 9,240 if the chair is a woman, which works out to be 18,480 different ways of constructing the committee if the chair can be a senior, whether the senior is a man or a woman.